Now we're going to talk about another shape called an ellipse. On a graph, there are two different types of ellipses, one that's horizontal and one that is vertical. Each different type of ellipse has its own standard form. For a horizontal ellipse, the standard form is x minus h squared over a squared plus y minus k squared over b squared equal to 1. In this situation, a is always going to be greater than b. There are vertices of an ellipse, which are the 2 points on the ellipse that are the farthest apart from each other. And those points, those vertices, are at h plus a, comma k, and h minus a, comma k. Then there are co-vertices, which are the two closest to each other that are across from the ellipse. And that's at h, comma, k plus b, and h, comma, k minus b. And then we have these things called foci. The singular version is focus. The foci are these 2 points right here, and those are at x plus c, comma k, and x minus c, comma k, where we find c using the equation c squared equals a squared minus b squared. This is not the Pythagorean theorem. We're not adding, we are subtracting. For vertical ellipses, we have very similar situations, except in our standard form, a and b switch places. This time a squared is with y and b squared is with x, so then that switches the vertices. Here it's going to be k plus a and k minus a for the vertices. For the co-vertices, it's going to be h plus b and h minus b, and for the foci, it's going to be k plus c and k minus c. That's a lot of information. Let's look at an example. We have x squared over 25 plus y squared over 9 equal to 1. So just by looking at this, we can tell whether or not it's horizontal or vertical. If the bigger number, the bigger denominator is with x, that means it's going to be a horizontal ellipse. Horizontal. So when we're graphing this, it should be pretty long width-wise, not very tall. In our numerators, with the x and the y, we're not adding or subtracting anything, so our center is at 0, 0. Now for the vertices, we need to figure out what a and b are for vertices and co-vertices. So we need to take the square root of each of those denominators. The square root of 25 is 5, so a is 5. The square root of 9 is 3, so b is 3. For our vertices, since it's horizontal, we take h plus a and h minus a, comma, k. So 0 plus 5 is 5, our k value is 0. 0 minus 5 is negative 5, our k value is 0. For the co-vertices, h doesn't change, this time k does. We do k plus b and k minus b. So our co-vertices are at 0, 3, and 0, negative 3. Then we need to find the foci. That's where we use c squared equals a squared minus b squared. So let's see what that comes out to be. So now that we have c, c is 4, then we're going to take h plus c, comma k, and h minus c, comma k. So we have 4, 0, and negative 4, 0. I'm going to go ahead and plot these points, then we'll figure out the major axis and minor axis in a second. So we have a center at 0, 0. Our vertices are at 5, 0, and negative 5, 0. Our co-vertices are at 0, 3, and 0, negative 3. Our foci are at 4, 0, and negative 4, 0. So let's go ahead and connect those outer dots. Remember, the foci are not on the edge of the ellipse, they're inside of it. Now for the major axis, that's the equation of the line that connects the vertices. So we have vertices that are both on the x-axis, so we need the equation of this line. Since it's horizontal, it's going to be y equals, and the value of y on the x-axis is 0. The minor axis connects the co-vertices, so in this case our minor axis is at x equals 0.